okay? Okay. So let's look at this one. What we have? We are talking about Barron's books. You know the Barron's, they have, you can buy those self-study books for GMAT, GRE, LSAT, MCAT and all those things. So let's say we are talking about that kind of a book for GMAT exam, and these candidates, they have been using that book for 2 decades, and a study was done and they found out that on the average a person took 240 hours to complete this self-study course. So our mu is 240 and our standard deviation is 80 hours. So those are given. Now the first question is, what is the probability that a candidate would take more than 300 hours to complete the program? So let's draw the diagram first. Our mean is 240. The question is more than 300 hours. So 300, that should be on the right side of this normal curve. Let's say it's somewhere around here. So more than 300, we are looking at this area under the curve, right? So how many z-score we are going to calculate? One z-score for 300. So we will write z 300 equal, using that formula, our x, that is this one here, minus mean, which is 240, divided by standard deviation, sigma is 80. So this is 60 divided by 80, which is what? 0.75? 0.75. So this is the z-score for 300. Now we need to look at this table and find out the area for 0.75. Now if you go down the first column, then look for 0.7, and then you go to your right until you find 0.05. So what do we have? 0.2734. So the corresponding area to this z-score is 0.2734. Now this 0.2734, that is this area here, right? But we don't need this area, we need this area. And we know half of this area is 0.5, so we'll be writing the possibility that a candidate will take more than 300 hours is, it will be 0.5 minus 0.2734, which is 0.2266, and in terms of percentage it will be 22.6, right? So now we know the possibility that a candidate will take more than 300 hours is 22.6%. So that's how we do it. Remember one thing, when you are using that formula, always remember that z-score you are calculating, that is going to give you the area from the mean to that point. It could be on right side of the mean if the number is higher. It could be on the left side of the mean if the number is lower. Let's look at question number 3. We have a number which is lower than the mean.